you were, but now very less.
Same for everyone. Like, is anyone else able to hear me?
No, I can't hear you at all.
Hey, your voice is slow for me also.
Sandeep, initially when you spoke, you were okay, so then somehow it reduced.
I'm trying to fix it.
Yeah. In the meanwhile, yeah, now it is okay. Yeah, please tell.
Okay, so what's happening is like MS Teams sometimes does not give the notification of chats that are happening in the channel, sir. Like, it's not always the problem, but sometimes it does not give, sir. Like, the last notification I personally got was the posting of PDF regarding the project ideas. After that, the link for the Google form also, that like usually we get a mail or at least a notification saying that some activity has happened in the channel, but it's buggy. Like, sometimes it happens and sometimes it doesn't. So I think important stuff like that, if it is also communicated through mail, I think that would be better.
So what about, I think you are talking about the posts that the TAs are making, no?
Yes, sir. TAs or anyone, sir, even comments and replies as well.
No, who is making the comments? Because I did not post anything through Teams.
No, sir. Like, some TA posted a Google form link to fill the Teams.
Yes. No, so I would request that if there is some post from the TAs, I would request that TAs please do so from Moodle. Okay. So Moodle, actually they will send you an email, right?
So even that or mail is also fine, sir. Like,
no, mail is fine. The main problem I will tell you with the mail is that it is very disorganized, right? So, if I do it through ERP, that is not a very good interface, right? So I would prefer to have it through Moodle. I think that is better. And even you can do, as I told in the first class, that so at least once or twice a day you should check your Moodle, right? For all courses, in fact. I mean, not just, because most of the courses are using Moodle, I believe, right? So I think that would be a good practice. But this, thanks for bringing this up. So I request once again the TAs don't rely solely on Teams, right? Do things through Moodle, right?
Yes, sir. Like, actually, I saw the form to fill the Teams name today in the morning, sir. Then we filled. So
Is
why
that
I
right?
wanted to.
Okay. Anything else? Otherwise, we can start. Okay. So we'll start with a recap. And as usual, so let me just first share with you.
Sir, you are muted.
Sir, you are muted.
Yeah, but I did not mute myself. That is what I was asking. Who has muted me? I do not know. Somebody muted me.
Sir, by mistake I did actually. I was pinning your frame and by mistake I clicked on mute.
Okay, is that you can mute me also? Anybody can mute anybody else?
Yes, sir.
Okay.
Because we are all we are not organized. Like, when they are attendees, they cannot do, but in normal meeting they can.
You can actually change that settings, sir.
Oh, is that
Yes,
right?
sir. That
Yeah,
only organizer is presenter and rest all are attendees.
Okay. So anyway, so let us continue. Yeah, so let us do a quick recap before we start some new topic. Okay. So what is hybrid cloud computing? Hybrid cloud computing.
A mixture of public and private cloud.
Mixture. I mean, it's not a very good term, but it's okay. So, I mean, you understand what it is, right? Anybody else? Same thing, but I would like you also to speak, right? So, Sontu, what he has said is correct. But, if others also speak, that is better, right? So, when I ask for others, you should be speaking as well. That way, actually, I mean, the reason I do this is that if you speak, you will remember for future, right? Okay. So, try to
This one private cloud that interacts with public cloud services as well.
Yes, yes, that's true. So hybrid cloud computing is a combination of both private and public cloud. Not like the term clouds, right? There is nothing called clouds, right? So, but it's okay. You understand what is implied. Acha, this one is little different. Why is superior orchestration needed for hybrid cloud deployments? Snehal, I see you. I can see others also, but Snehal, please try to respond. Unmute yourself.
Not sure, but
Rohini, you are not visible. What happened?
I'm not sure, but because you have to manage the private cloud while it is actually taking requests from the public cloud, so maybe that's why it's more difficult to deploy the hybrid cloud, and you have to have extra requirements.
Snehal, your intuition is very good. Okay, so we'll look at the exact answer. But before that, anybody else? Sudatta? Sudat?
Yes, sir.
Yeah.
So mainly because just like Snehal said, uh, it is more which because the private cloud is the interaction with the public the public cloud is open to all, and the some services are there is a distinction between private and public cloud. So in this scenario we need to make sure, because if we are designing in such a manner implies that there are some resources or some behaviors are not accessible to everyone. If we make a mistake in the configuration, then it might cause the system to collapse, or it might be a vulnerability of sorts.
Ria?
Yes, sir, because in case of private cloud, we cannot access all the services. That's why superior orchestration is required. That's why hybrid cloud deployments are required in superior orchestration.
Okay, so hybrid clouds need to accomplish tasks as a combination of privately available cloud and the public cloud, as we have seen before, right? So this requires sophisticated techniques, both for resource management and task orchestration. Okay. Next, which of the following must include both private and public clouds? Which of the following must include both private and public cloud? Multi-cloud, hybrid cloud.
Hybrid cloud.
Hybrid cloud.
Hybrid cloud.
Okay. So the answer is hybrid cloud. Multi-cloud may or may not involve private cloud. Hybrid cloud must have both private and public cloud models. Next question. Which of the following cloud computing models does AWS EC2 belong to? You know, this is, I think most of you know AWS is a public cloud, right? So they have this, this kind of service, EC2. So, is it infrastructure as a service or platform as a service or software as a service?
Sir, it is infrastructure
Infrastructure as a service.
Everyone, infrastructure as a service?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, very good. You guys are quite knowledgeable. Infrastructure as a service. Okay. In resource lifecycle, deep provisioning resources occurs after which of the following steps? Request step, release, execute, none of the above.
Release date.
Release.
Release date.
Release date, sir.
You remember
Release step.
exactly what we spoke last
Release
class.
date.
Very
Release
good.
step.
Okay. So deprovisioning occurs after releasing the resources for returning it back to the resource pool. Very good. Okay. So we will now switch And I do not know whether, are you able to see my slide, the next set of slides?
No,
No,
sir.
sir.
No, sir.
Okay, again, I think I have to share once more, right? Yeah. Now is it visible?
Yes, sir.
Yes, sir.
Okay. So before we do, before we start, I would like to discuss something with you, right? So, let us talk about the history of cloud computing, right? So you guys, in one of the previous classes, we computing, right? You remember that one of the earliest forms was client server computing, right? And I think that this basically is known to everyone. Basically, so everything is at the server, and you send clients send some requests. The requests are fulfilled at the server, and the response is sent back to the server. To the client, right? So after client server computing, basically what evolved was distributed computing, right? So distributed computing came into picture. So basically, what you have are different computers, network resources, etc., which were distributed, throughout, right? So in some geographical, terrain or something, not terrain, basically, in some, basically distributed geographically, right? So all across different countries, or even within the same country, different locations, etc. So that is how distributed computing came into being, and we spoke about it, right? In the initial classes, we discussed about how distributed computing, so what it is about, and so what are the different features of it, right? So cloud computing basically around 2000, right? So I think if I remember correctly, around 2000, it started, becoming popular, right? So early 2000, basically early 2000, it started becoming popular. So basically, the whole idea was to use some of these concepts of distributed computing, including cluster computing, grid computing, etc. So have all of them different ideas taken from different technologies, and putting them all together with the topping of utility computing, right? So 1961, basically, there was this idea of utility computing, which was proposed by an MIT scholar, John McCarthy, and he came up with the concept of utility. He spoke about in his speech in 1960s, right? He spoke about how computing can be sold like an utility, right? So, and this we already discussed about what is this utility, just in the same way as you have water and electricity as utility, so how this can be done, right? So this basically caught attention after, at that time, and later on, it evolved, right? In 1999, this company, Salesforce.com, they started delivering different applications to users through their, website, right? So Salesforce.com, which is basically a SaaS kind of cloud, right? So they started delivering different types of applications through their websites, through their website. Then in 2000, basically, Amazon, they started their Amazon Web Services, 2002 roughly. So 2002, Amazon started offering Amazon Web Services, right? So even like EC2, etc. In 2006, it became a commercial product, right? Then Google came into picture, right? 2009, Google Apps started providing cloud computing enterprise applications, right? So Google became popular around the same time. Microsoft also, they launched their Azure product, Windows Azure, right? So that was around the same time, 2009 or so. And then so there are different other companies like Oracle, HP, and nowadays actually almost all major players, so they have some kind of a cloud service. Not almost, but many of the companies, they have their own different cloud, so cloud offering, right? So this is how actually cloud computing became gradually popular, right? So now when we speak of cloud computing, there is something. Is my slide visible?
Yes, sir. Yes, sir.
Yes, sir.
So when we speak of cloud computing, in fact, like other technologies also, we need to understand the architecture, right? So architecture forms the basis, architecture forms the reference for many technological developments, right? So for many technological developments. So for cloud computing also, there is the reference architecture which is very important. So I told you about the evolution, chronological evolution of cloud computing, starting from Salesforce.com in 1999 to different other companies, including Google, Amazon, and other companies who also joined the league. So so basically NIST, which I think many of you are already familiar with. NIST, National Institute for Standards and Technology, or something like that is the full form. Please check it out. I do not exactly remember, but it's basically a National Institute for Standardization, right? So that is based in US, right? So NIST, they came up with the reference architecture for cloud computing, right? So they came up with the reference architecture for cloud computing, and so there are different components of that cloud architecture, and that kind of this NIST architecture is used quite widely in many of the cloud technological developments. So we will speak about this particular reference architecture for cloud computing, right? And we will also eventually, not today, eventually in maybe tomorrow or so, we'll talk in more detail about this infrastructure as a service, platform as a service, and software as a service, right? And in this module, at the end, we will talk about something called microservices, right? And this is a very interesting thing. So we'll talk about what is this microservices, and what are the different attractive features of these microservices. So when we talk about cloud computing, right? So cloud has the front end as well as the back end, right? So we'll look at both the front end as well as the back end architecture. So front end is basically the one which interfaces with the end users or the clients, and back end is anything beyond, anything behind what the users do with the interface, right? So backend is basically typically used by the service providers for managing the services and the infrastructure, whereas the front end is the one that the end users do and end users interface to interact with this cloud platform. Typically, this front end is some kind of a web form or something of that sort, right? So some kind of a web interface through which the end users or the clients, they connect with the cloud service, right? So you have both the front end and the back end. So in addition to the front end as well as the back end, in the cloud reference architecture proposed by NIST, there are multiple different other components. So this is how. So Rohit is requesting control. Why, Rohit? What is the matter? So please do not disturb the class. Huh? So if it was done accidentally, then it is fine. But please do not do intentionally and disturb the class. Anyway, so NIST architecture looks like this, right? So this is the pictorial view of the NIST reference architecture. So those of you who want to get better understanding of this particular architecture beyond what I tell you over here, please look at the source, the reference that is given for you, and it is publicly available. So please go through it and try to understand what are the different individual components comprising this particular reference architecture. So as I told you that there is a front end and there is a back end, right? So you see that in this architecture, you have the cloud consumer And then you have the cloud provider, right? So this cloud consumer basically are end users like me and you who want to get access to or who want to use any kind of cloud service. So we are the part of the cloud consumer. And cloud provider, let us try to understand this cloud provider. So this cloud provider basically has different individual components. One is called the cloud orchestration. Second is the cloud service management. Third is security, and fourth is privacy. So these are the four main building blocks of cloud provider. So cloud orchestration in turn has three major components. One is called the service layer, second is called the resource abstraction and the control layer, and third is called the physical resource layer. So this service layer is actually the core of all the different computing services that are offered to the end users. So service layer has software as a service, platform as a service, and infrastructure as a service as the three different primary service offerings that cloud started cloud started offering, right? So the service layer basically has software as a service, platform as a service, and infrastructure as a service as the three primary computing services that are to be offered. So service layer. Then comes the resource abstraction and the control layer. So resource abstraction and the control layer I will talk about after we discuss about something called the physical resource layer. Physical resource layer is the one which basically talks about the actual hardware, the actual infrastructure, the actual computing infrastructure and hardware, and the facilities that are used. Facilities basically include the networks, the routers, the switches, etc. So hardware facility, all of these put together, this becomes the physical resource layer. So physical resource layer, as this name suggests, is basically comprised of the physical, the actual computing resources, right? So these actual computing resources will have to be offered in the form of services. So between the service layer and the physical resource layer, there sits this particular layer which is called the resource abstraction and control layer. So this resource abstraction and this resource abstraction and control layer is basically the one which abstracts these physical resources and offers certain kind of control mechanisms in order to use these different resources and offer different services like SaaS, PaaS, and IaaS. Right. So these are the three main components or subcomponents of this this cloud orchestration block of the cloud provider. And this is very important in terms of what the service provider does in terms of offering these different services. So these three main blocks or sub blocks under cloud orchestration are very important and core to the offering that is made by the cloud provider. Next, we go to the next one, which is called the cloud service management. So cloud services, earlier what did we have a look at is basically you have these different physical resources, you abstract these resources, and then you offer these resources as different types of services. Right. So parallelly, what you also need to do is you need to have some kind of management of these different services. So these different services that we talked about, SaaS, PaaS, and IaaS as part of the service layer, these will have to be offered in the form of different types of services. So you have cloud service management. So you have cloud service management, which takes care of the management of these different cloud services. And in turn, it is comprised of three different blocks. One is called the business support. Second is called the provisioning or configuration, and third is the portability or interoperability. So let us try to understand what this business support is all about. Business support basically talks about the business rules, the different types of service level agreements, the business rules which will have to be embedded in order to offer these different types of services by the cloud provider. Right. So these business rules business SLAs, etc. These are basically part of this business support. Then comes the provisioning or configuration component. So in provisioning or configuration, typically what we are talking about are these, these physical resources are there, they are abstracted, but then different users, cloud consumers, these different cloud consumers and the users, they have their individual requirements. So these individual requirements will have to be taken into account in order to offer these cloud services. So this management of this individual requirement and provisioning them, packaging them, and offering these different services, this basically is taken care of by this particular component, which is called the provisioning or configuration, right? And then you have the portability or the interoperability. Here basically, as this name suggests also, so taking care of these individual resources which are distributed all across, making sure that they the services that are running on top, these are using these hardware, etc. And there is interoperability and portability of these different resources based on these different user requirements that come through and will have to be provisioned accordingly. So for that, this portability and interoperability basically helps in offering this kind of thing. So this is basically the cloud service management. And then the other components like the security and the privacy, basically, as you see, these are running all across, which means that these will have to be the security of the system, security of the information, so whether it is system level security or whether it is information level security, these will have to be built into. And privacy, obviously, because you are talking about data which are being distributed all across, and you do not know, you means who? The cloud consumer. You do not know where your data are going to all reside. So this privacy will have to be also taken care of and will have to be dealt with in order to have a successful cloud model. So all of these different components, the 4 different major components that I talked about: cloud orchestration, cloud service management, security, and privacy, these will have to be packaged together, and these will have to be taken care of by the cloud provider. So well and good, but then there is something that will have to be done between the cloud consumer and the cloud provider. So this is where, in the same way as you have for any service offering, you have some kind of a brokerage service, right? So if you, for example, right, so when you go to maybe a hospital, for example, right, so there are you will find that in major hospitals there are different brokers, right? So hospital basically is the service provider, and you have different brokers which can help the individual clients, the patients, etc., to get some healthcare services in an improved way, right? Have access to these services in an improved way. So here also you have this cloud broker, which basically takes care of some kind of an intermediation between this consumer and the provider in terms of the services that are offered, in terms of the aggregation of the different services. See, what is this aggregation of the services? So there could be, if you are talking about multi-cloud or even for like simple cloud also, right? So you have different services being offered, right? And how do you aggregate these services and provide those services to the end users based on these end user or the cloud consumers requirements? This will also have to be taken into account, right? So you have service intermediation, you have service aggregation. Now, what is this service arbitrage? Arbitrage means that based on these different requirements, so basically this service provider, they are going to take these different individual components from these different distributed resources, and they are going to offer they are going to ensure some kind of a service arbitrage, right? So that becomes the cloud broker. So cloud broker basically offers brokerage services for computing and assists the consumers as well as the providers in having these packaged and improved service offerings made by the cloud provider to the consumer in an improved way. Then comes the cloud auditor. So cloud auditor is basically typically it's an external, it's a third party, right? So cloud auditor is typically a third party which takes care of all these different types of audits, ensuring that there is no security breach. The system basically secures the data, etc., ensures privacy, etc. So security audits are done, privacy impact audits are done, and the third one is very important, which is called the performance audit. So basically, whether the cloud provider provides the cloud services with desired performance, that will also have to be audited by a third party. So this cloud auditor is a third party which takes care of external audits like security audit, privacy audit, and performance audit, performance of the system, right? So these are the main building blocks of a cloud platform as per the NIST architecture, which is widely used for building cloud systems. And at the very bottom, you have basically the cloud carrier, right? So these are the different components of this NIST architecture. Now, what I'm going to do is, any question on this part? Okay, so now what I'm going to do is I'm going to show you something interesting. What happened? I hope that all of you are with me. Can somebody confirm?
Yes,
That you are not disconnected?
Yes, sir.
Yes,
Okay,
Yes, sir.
very good. Okay, so now we will play some video. Okay, just give a moment. Nidhi?
Yes, sir.
Yeah.
So is my screen visible?
Yeah, it is visible.
Okay, sir.
Nidhi, I think the audio is not coming.
Oh, okay.
When cloud architects set up a company's cloud environment, they are organizing it around four chief concepts. 1. Cloud infrastructure, the underlying compute, storage, and network systems. 2. Cloud delivery model, the client side and provider side of the cloud platform. 3. Cloud service model, the type of service offered such as IaaS, PaaS, or SaaS. 4. Cloud deployment model, this relates to the approach and governance of the cloud platform. Let's take a closer look at each of these concepts. 1. Cloud infrastructure. Cloud infrastructure contains the estimate, network, and storage systems on which cloud services run. Cloud infrastructure typically leverages virtualization to create pools of resources from the compute, network, and storage building blocks that can be programmatically managed and elastically scaled. To be defined as a cloud computing platform, a vendor typically will offer a portal for on-demand self-service. The service will also provide monitoring capabilities and often use metered billing. 2. Cloud delivery model. The end-to-end delivery of cloud-based services may include a front-end platform, client computer, mobile device, or IoT device, and a back-end platform, the pool of virtualized resources. Clients access the cloud environment using the internet or in some cases a virtual private network, VPN, link. This could be using a web browser, mobile app, or client-based software. The backend includes the pooled cloud infrastructure resources, data, and applications. This is typically delivered out of multiple data centers for high availability and disaster recovery. 3. Cloud service model. You may be interested to learn what types of services are most common with cloud technologies. Let's go through a few of the most popular examples and look at the cloud service model they are associated with. Infrastructure as a service, IaaS. This is a cloud service model where a cloud provider offers virtualized servers or instances. As a consumer, you can request the resources your instance requires, such as CPU, RAM, disk space, and the operating system. Resources can be requested programmatically, using a REST-based application programming interface API, or through a console. As a consumer of this service, you are responsible for managing the operating system and any applications installed. The cloud service provider is responsible for ensuring the availability of the underlying resources. The most popular example of an IaaS service is the Amazon Web Services, AWS, Elastic Compute Cloud, EC2. With Amazon EC2 you can quickly and easily launch a virtual server in the cloud from over 70 data centers in 22 plus regions around the world. Platform as a Service, PaaS. You may want to reduce the management overhead of some aspects of your cloud service. For instance, you may want to reduce the burden of tasks such as operating system maintenance, patch management, and middleware management. In that case, a PaaS service may be for you. With PaaS, the operating system and also the application middleware such as the Node.js runtime, Net runtime, or Docker engine, are delivered to you as a managed service. The key benefit of this model is that you, as a consumer, can easily deploy software applications with minimal configuration or operational overhead. PaaS is favored by cloud developers as their priority is to deploy and test their code. PaaS allows them to do this quickly and easily, enabling agile software development and continuous integration and delivery. C/CD models. Examples of PaaS services are Microsoft Azure Web Apps and AWS Elastic Beanstalk. Both of these services provide fully managed platforms that perform OS patching, capacity provisioning, servers, and load balancing. With both IaaS and PaaS, you are typically charged under a pay-per-use model with no fixed contract. However, significant discounts can sometimes be found by locking in for a fixed-term contract. Software as a Service, SaaS. You will probably be most familiar with SaaS services. In the consumer world, SaaS services include Facebook, Gmail, Instagram, and cloud storage services such as Dropbox. Corporate examples containing Salesforce.com, Office 365, and ServiceNow. In the case of a SaaS service, the consumer has very little control over the configuration of the software service. On the positive side, you also don't need to worry about the platform, data, or applications as this is all managed for you. 4. Cloud Deployment Model. Now that you understand the architecture of a cloud-based service, let's examine the deployment models. You may have heard the terms private cloud, public cloud, hybrid cloud, and multi-cloud. These terms relate to the dedicated or shared use of a cloud service and its governance model. Private cloud. If you build one of the cloud services mentioned above in your own data center for your company's sole use, this is called a private cloud. However, if the cloud is dedicated to a single tenant, this would make it a private cloud. With a private cloud, you have more control over the design and implementation of the stack and even the hardware and software of which it's comprised. This flexibility may come at a cost as this type of cloud can be expensive and there are limits in its scalability. Public cloud. With a public cloud, a third-party organization, such as AWS or Microsoft, offers access to its cloud services to large amounts of customers. The cloud platform is multi-tenant, allowing many consumers to run services on the same underlying hardware. Due to massive economies of scale, public cloud services can be very cost-effective. The scalability is almost limitless, so you can grow your business fast on these platforms, paying only for what you use. Hybrid cloud. A hybrid cloud refers to the use of private and public clouds by the same organization. Typically, this will include VPN links to connect the clouds together and may include features such as the ability to burst workloads into the public cloud as necessary. You may want to create a hybrid cloud architecture to gain the benefits of both public and private cloud options. This is advantageous when the requirements of specific applications are better suited to one deployment model over the other. Multi-cloud. Sometimes an organization may benefit in utilizing the services from multiple, disparate cloud service providers. These services could be offered in managed, or on-premises, private clouds and public clouds. The use of services from numerous cloud providers upshots in what is frequently known as multi-cloud. An instance of this setup could be utilizing both Amazon EC2 and Microsoft Azure Web Apps. Again, you may want to use a multi-cloud architecture when you have different applications that are better suited to one cloud deployment model or provider over another. For example, you may find that your Microsoft applications are better suited to Microsoft Azure, while your non-relational database requirements are better served on AWS.
Yeah, I think so today. So today we will not go through anything new. Nidhi, you can stop sharing. Yeah. So what we will do. So I hope that so you all have understood because most of the stuff were already covered so far. So I hope that this video basically helped you to make your understanding firmer beyond whatever I already said. So I just so is there any questions so far? So
Sir,
in that case,
sir, in the
anybody have a
hybrid
question?
cloud, yes, sir, I'm Otanu.
Hmm.
In the multi-cloud and the hybrid cloud, like, where is the distinction between the two?
So basically, the way I mean, this is just terminologies, right? The way I see, I mean, see, the whole idea is that in hybrid cloud also you are using both public and private, right? So there also you are basically, so you are, so see in hybrid cloud. So let me ask you a question before I go a little ahead. So from the video, if you have seen carefully, they talk about how, how and where these hybrid clouds are required. So where is basically most of these institutions, right? So what they do is they use part of this public cloud, sorry, this public cloud, and the other one is the private cloud. Now, how are these public and private clouds connected?
Through VPNs.
Through VPN. Very good. Through VPN, right? So, so this is how this hybrid cloud works. So multi-cloud, as I understand, is basically so different, several let us say several public cloud or whatever, they could all be connected together and be they can or an organization basically can be using several services from these different cloud and put them as multi-cloud, something like that, right? So I also do not have clear understanding exactly about how multi-clouds work, but this is what I would assume, right?
Okay, sir.
Yeah. So yeah, what else? Yeah, so regarding the now let us discuss about the project, right? So project, what is the situation? So all of you have started, you have formed your groups because you have to coordinate with Chandrani, right? I have not taken stock of the situation, so but I'm just assuming that everybody is in a comfortable position and the groups have been formed and you guys have started working. Have you? Because we are almost like towards the middle of the semester, right? And if you have not started working on this thing, then you need to basically think how you can manage your time forward, because always, as you know, that latter part of the semester becomes busier, right? So what is the situation? The groups have been formed. Chandrani, could you please update?
Yes, sir, there are some groups of formed. So I get 16 project names from the students. So apparently 49 to 50 students are there who are already from their groups, and there are some queries also there. So it is asked that is whether single one, say project single student is
Chandrani, I
allowed
can't
or
hear
not.
you properly. With so much of background noise, could you keep your mouthpiece closer to your mouth? Yeah,
Okay,
yeah,
and I'm audible, sir.
yes, yes.
Okay, so there are total 16 list which I get. So from the 60 list, I get some of the project names. And there are some repetitions also there. So already 49 to 50 number of students from their groups. So
Okay,
some students are also left. So I think I will get the list today.
okay. So please finalize by today if you can. I think
Okay.
Sandeep, like you, probably if you may not have got the notification, right? So just work it out with Chandrani. Chandrani, please consider, right? Because they are the ones who genuinely did not get the notification, right? So henceforth, please try to uh, pass on these kind of messages through this thing, Moodle.
Moodle.
Okay.
Okay, sir.
Yeah.
Sir, this is
And I
Pallav.
would also request all students also to at least once a day you should check your Moodle, at least once a day. Yeah, somebody was saying something.
Sir, this is Pallav. So
Yeah.
there are a few students who were raising concerns that they could not form groups and they are currently matlab, alone. So what I had suggested them is they can send us a list of who are alone and maybe we can club them, or otherwise they can work on the project solo.
Yeah.
So is
Yeah,
that fine?
solo is okay. Yeah, so if somebody prefers, right? If somebody prefers to work alone, that is perfectly fine, right? Because sometimes, I will tell you that sometimes some students have difficulty forming groups, right? And it doesn't mean, it is not like any kind of a negative thing, right? So sometimes students prefer to do things on their own, and so we should allow them to do the things on their own, do the project on their own, right? So perfectly fine, right? So if somebody wants to do on their own, but so we also have to, Chandrani, we also have to take into account the individual effort. Let us say that you have a group where 4 students have done the work to do something, and on the contrary there is another group which with only 1 student,
Okay.
right? So we cannot bring them at par, right? 4 students, we should get 4 times the individual effort that is expected, right? It should not happen that 4 out of the 4 students, 3 students have taken the back seat and only 1 student took the front seat, right? So it should not happen that way. And so we have to judge in a fair manner that all students have been treated equally.
Okay, sir. So that's why I'm saying that all the students must take participate in the interactions and they have to give their own presentations. And in the final presentation, all students must take part.
Yes. Yeah, so everybody has to contribute, right? So please make sure that all your group members contribute. If you hide this fact, basically, you are doing harm to your friends, right? And do not feel shy to ask your group members to contribute equally. I think, at this stage, most of the students over here are all matured students, right? So at this stage, they understand what has to be done, right? Okay, so that's all. Anything else? So can we expect by tomorrow we'll have a go ahead from your side, and students they know what they are working on and they can start they are working on the project immediately, because for students, for you also, try to start working on the project if you have not already done so as soon as possible, so that you do not feel stressed later on, right? It's very important. And do not, we gave you flexibility. Do not take up any project which you will not be able to fulfill. Your individual load, right? Take up something that you will be able to complete. And at the same time, of course, we also have to agree with whatever you are saying. It cannot be like, you take up a very simple kind of thing and you cannot be treated equally, right? So it should be balanced, and I leave it to you. And please, you start working on this thing after you have fixed the project. Okay, so already we are over time, and I think we can stop over here. All the best with your projects, and please finalize by today. Tomorrow I will be asking you individually, what your projects are. Okay, thank you. Bye.
Thank you, sir.
Thank you, sir.